Alright, Alice, you ready to take a ride on the pain train? So, from last night, this being Berkeley's final integral tool where you get 5 minutes on 5 math questions that are going to be this, and you got to figure out what it is. So, for me, again, I've been using Big Bang. I've been using some of the notation on the clues of the first star origin or the black hole. It doesn't matter. Doesn't matter which one of those that is, neutrino, durium, tritium, whatever, cosmic whatever's in the bubble or the pipes. See, it's both squared and circled for what it is. So I just want to we're going to keep some of this up here and we're going to slide back into string theory on the orientation of
Hello, wonderful
wording.
person, this is Anton, and today we're going to be talking about the idea of cosmic dawn. The idea behind the beginning of the stars and beginning of the light in the universe.
So that's kind of a big macro, micro topology problem on smooth and globular nature of collisions and this type of fusion. This Lorenzo for orientation of why causally it's relative to be on timelines here, because we're talking about something real big on.
Or essentially when the universe produce these first stars with the first
so
light
when you get into whatever I'm going to talk about, again, it still applies in the same way. Well, this is the lens.
It's also a mystery that even today does
You're going to need to know some of
resolution.
this numbers, take out temperature differentials, because they matter. At those levels, when you're still playing with this type of mathematics, it has density sheets in the pipes. Hubble Deep Field would be Carl Sagan Universe Loaf on Penrose. So it's going to density difference based on time, X, Y, and Z, being some of that notation inside of here. Twistor theory. Like I said, there's a reason he's bored, him and Carl Sagan, for 2020.
And
now,
so essentially the goal is
you would have to
find
think
the farthest galaxy
of
and
what
then
is
to try to calculate its age.
peg
And
on
this way
this, a
we can maybe
ping
work out
or
when
whatever,
these first stars came
M1
into
and
existence.
M2
But
variable inside
unfortunately,
here.
it's not very
It's
easy.
fun.
Even
It's
Hubble
good
reached
graffiti.
its limits
I
when it comes
don't
to
mind
certain
it.
distances.
But like I said, this little
And although
square,
the scientists today expect the James Webb Telescope that's going to become operational soon
Murphy's
to
Law about
possibly
rapid
help us see even
acceleration,
farther
not
and
just
find
if
some
it can go
other
wrong, it will go
galaxies.
wrong.
The only way to try to figure
Well, you have
all
to get
this
used to
out
this
right
kind
now
of
is to maybe
gridding.
look at some of the most distant galaxies ever
Okay.
found and to then try to discover their age. Now this is
And
exactly
so in
what
that
the
box
scientists
there's a real
behind
person.
this paper right here
There's a real
decided
player
to do. They chose 6 galaxies that
banging
were
around on
assumed to be some of
some
the
of
most distant
what
ever
that
discovered,
would look like
and used
in
several
lensing.
very well-known techniques to re-establish their distance and to also then calculate their
So
age,
again, you know, for me,
which
again,
would
I
then
also
allow
use
them
this for
to
stock.
possibly
Well,
predict when the
telescopes
first
you
stars
need,
appeared in
equipment
the
that you gotta
universe.
have
But
on
this is when I became
what
super
are
curious. How
what
could they
are
possibly
right-hand
achieve
rule
this?
paradoxes
First of all,
on
these
that.
galaxies are
The
ridiculously
left-handed
far away.
systems,
So
and if
far
I
away,
wanted
as
to
a
throw
matter
up
of
a
fact,
couple
this
of
is not at
calculus
all what they're
teachers,
seeing in their images.
it would be a
The
blink
actual appearance
wink
of these galaxies is
kind of a
something like
system
this.
with
It's
CT
just a few
paradox
tiny pixels
inside of
that are
that
barely
about
distinguishable
neutron
to
star
be a galaxy
collisions.
to begin with. Now here they can
In
obviously do a
quantum space or
spectroscopic
quantum
analysis and
time,
discover what kind of light is coming from them. But how can
whenever,
they possibly determine a distance to this and then
it would
determine
lens
its age?
quite
And
considerably.
there's
And
actually
then
a
the
brilliant
usefulness
technique
of
to
that.
do all
We'll get
this,
into the
a technique that
neutrino,
was originally
right?
discovered
30,
over
the
100 years ago. Here's how it
66.6%.
works. When excited hydrogen atom starts to cool down, it emits ultraviolet light at
13.7%,
very specific
13.5%,
frequencies that are
13.5%,
directly
or whatever.
related to the
So
energy
you get
levels
into
of the
every
electrons
matrix
inside
set
the
of
atom
what
itself.
that is.
Today
And
we
you say
refer
that's
to these
S,
as
you say
Lyman
that's
lines, with the
whatever
lines
field
themselves
type you're
forming
doing it.
something that
This is
looks
part
like
of it,
this.
graphing,
Now this
X, Y.
wavelength is in a unit
I need to
known
know
as angstrom, but
O-type
it can also be obviously
stars
converted
or
into nanometers.
supermassive black hole
This whole thing
numbers,
is usually referred to as the Lyman
cosmic strings
series,
crashing
and interestingly
together
enough, what
in
Lyman discovered
convergence.
is that they also possess a kind of a limit you see right here, which meant that the hydrogen atoms will
Minkowski in
never actually
space.
emit
So
any
he's
light
going to talk about that a
below
lot.
this
Anton
particular
Minkowski in
wavelength.
space
It's about
is
912 angstrom,
astrophysics.
or about 9
And that's not very hard to
nanometers.
see him
And
dominating
since
the
most of the
scoreboard.
universe is basically made out of hydrogen, especially early
That'd
universe,
be
the scientists
readout,
realized early
click,
on that by
readout,
looking at
N1
these
half,
Lyman series,
hot,
they
cold,
could
0,
actually
1,
start to
redshift.
analyze various
And so the
galaxies and,
program
of course, various
works
stars
how
across
I
the
want
universe.
to autonomously
For example,
program
it allowed us
a
to
definition of
categorize
a
various galaxies depending on the
Bell's
activity, also depending on
field
the types
theory
of stars
under
in them.
topic
So certain stars that are very
momentum
young, they'll actually
direction.
produce a certain
So
Lyman
whatever that
series
string
and a
theory
certain
is.
type of emissions not visible
The
in
string
other
being data
galaxies.
compression
And by
or
using these
data
techniques and by
compression in the
using
form
the
of
analysis
nucleus,
of
the
Lyman
origin of the
series from
first
nearby
star.
objects,
So that
scientists have also
Genesis
found a
on
way
build
to
fun for me.
basically determine ages
Oh,
of different
they usually
galaxies.
do.
So, for example, we know that the hydrogen signature usually increases
So,
quite dramatically as the
well, when
stellar
you
population
do comic
ages,
books,
but then
and I
starts to
mean,
drop dramatically once the galaxy
Avengers
is
have
slightly
different
older than a billion years or so. And by
contextual
collecting
Hellboy
the
over
data
here riding the
from
dragon.
thousands and thousands of galaxies, the scientists have worked out how to use these Lyman series to generally get the age of a typical galaxy. So, for example, some of the early galaxies that have a lot of these really massive, very, very hot stars burning a lot of gas,
Well, for me,
will
getting
burn
it
a
was
lot of gas very
resources,
quickly, and
timelines,
will thus
rabbits. We
contribute
can
to
track it.
creating a
First
much
things
stronger
first.
Lyman series signal, which can then be combined with
Telescope
some of the other
time.
observations to estimate the age. But over the years, while the scientists were looking at these galaxies in different types of light, they also realized that some of these galaxies have very peculiar features.
Well, of course they
Some
would.
of
They
them
would be
also
the
tend
start
to
of a
kind of
spiral
disappear at
off of
certain
all the vector
frequencies,
positions.
or to
Oh,
have
it's just
what's known as the
observation,
Lyman
and then
break.
your
Here's
students
what
in the
all this would
classroom
look
work the
like
same
for
way
one of these
too.
galaxies studied in this paper.
Now, I can
Suddenly,
make this
the
n one
frequencies
half
just kind of
congruent, find the
disappear.
area.
Which, if you look at
It
the paper,
wouldn't be
you'll see
just
that
the
it actually
students in the
happens for
classroom, it
all
would be
these
more
6
about
galaxies.
Penn's
And one of
rows
the
of
reasons
change
this
in
happens is really
topological
because of
system.
where
It's
these galaxies
in
were located.
gravity,
A
but
lot of these early
I
galaxies
know some of my
were
tricks.
essentially
But
surrounded by neutral hydrogen, this very opaque, very difficult to see through gas that sort of resembled fog. And this gas was
well,
very
then
likely
you're a
everywhere
stonemason
until
working in the
all of
stone.
the early stars and early
Eventually,
galaxies
Larry gets it.
started to emit
They
this
get
light,
it. Can't
which
do
then
this. Do
transformed
this.
it
Don't do
into
that. Can't
ionized
get away with
hydrogen.
this.
The
Sharp's
hydrogen
guy
we
will
have
pop up.
today.
Salty will
This
be
is
there.
usually what's referred to as the reionization era.
Beta
And so
out.
in pretty much all of these really distant galaxies,
And the
this
E1,
higher
E0, or
energy
E0
is
to E1.
completely invisible. It's absorbed by the neutral hydrogen gas. And this break is, of course,
So
right at
when
this
it's
limit right here,
a
the
scientific
Lyman
method,
limit.
usually it's a little bit
Generally
pure.
discovering such a
It's
galaxy just means that we found
when you
something
have a
really,
string
really, really
of
far away.
X, Y, and
But since
Z
the alignment limit
that
happens
can
in the
factor
ultraviolet
that
light at the
thing
frequency
to the
of
hard line,
9.12 nanometers,
wouldn't matter what we're
it would
adjusting
hypothetically
to.
be very
Or,
difficult for us to see these galaxies.
relatively
Mostly because we
speaking,
don't really have very
CT or
powerful
paradox
ultraviolet
or
telescopes
Andromeda to.
located on planet Earth. But we do
Are
have a lot of
we
infrared
there?
telescopes. But since the universe is expanding and since the
You can
light
do this
is
math
always redshifted
problem,
depending on the distance,
all
the
of
Lyman
us,
break from these
and
galaxies
we're gonna
transforms
see
from
what
being
we
in the
see
far
in there.
ultraviolet to usually
Infrared
near
for me
infrared,
again when I'm
which means that
trying
we
to.
can do two things here.
I'm trying to.
First of all, we can obviously discover them using various infrared telescopes, such as the Atacama Large Millimeter Submillimeter Array, also known as ALMA. And second of all, by determining the frequency of that observed Lyman break versus the
Wouldn't be
predicted
able to
Lyman
help
break,
it.
we can
Derivative
then
L
determine the
derivative T.
redshift and thus determine the distance. And so that's kind of how the scientists do it nowadays. They find this distant galaxy that has a very obvious
I
Lyman
have to
break,
remain to one.
usually
There's
in
no
near
way I
infrared.
can't.
They then compare it to what they should be seeing.
Black
So here's
hole
an
to black
example
hole.
of the galaxy used in this study, which then allows them to determine the redshift and thus the approximate distance to these galaxies. And then by combining
this is
with
a
the
graph.
Lyman
This is a
series
graph
that we studied
of
with other galaxies and other stars,
calculus.
they can then work out the age of all of this as well. And so by using those 6 galaxies and by determining their distance and determining their approximate age, the scientists were able to work out the approximate age of some of these first stars, and to also create this beautiful visualization you see
It's
right
there.
here, showing
The
us how
SAMs
the
are there.
early dawn
I mean, you
or
get the
early
45
cosmic
on the
dawn very
parallel, then you
likely
get space
happened.
times clocked this
According
way,
to them, the first
and then
stars
different
appeared
faster
somewhere
speeds.
right
You
here,
go
anywhere
backwards
from
in
maybe
time. Go
250 million years
left-hand
to
rule on
possibly
some of
about
this. If it
350
works,
million years
between
after
here
the
to here,
initial
man,
creation
think
of
the
the
universe cares? We got
After the
hydrogen
beginning
to
of the Big Bang.
Fallowvium,
Although
man.
this is
They're
for now at
118
least
on the
just a
periodic table.
preliminary discovery based on these 6
Mathematically, it
galaxies.
should. Now,
It's very likely that we might be
Oof.
able to discover some of the other galaxies even earlier than that, with some of the stars that are even younger. For now, though, these 6 galaxies
plasticity
do
factor, the
suggest that
human will.
the dawn of the universe, the cosmic dawn, very likely happened around this time. Which also means that the galaxies that we've discovered, these 6 distant galaxies, are anywhere from about 200 to maybe 300 million years old. They're still pretty young, but not that young. And this is, of course, something that's really important for
And
some
we're
of the future
talking
missions because we
the
need to
break
have some
line.
sort of a basis for future analysis. So, for example, as I mentioned, James Webb Telescope is expected to be able to see even farther,
So,
and so chances
if
are
we do,
the
we go back
discoveries
to
from this
the
telescope
train
are
and the
going to help
thresher.
us either to prove this or to possibly
How do you
discover something
how do you
completely
get
new,
through this
completely
and
unexpected. But at the
Hangman?
moment,
Oh,
studying
physics
twice at
Hangman
the
here.
cosmic dawn most likely
I
began
love
about
that. I mean, when you do the
215
math,
million
you see
years
it.
after the
Oh,
beginning
so
of
yeah,
Big Bang.
all
Notice
this
how I didn't
number.
say the
What,
Big
what?
Bang, because the Big Bang never really finished. It's still going on even today. But that's something we'll discuss in some of the future videos, so make sure to subscribe. Either way though, this is a really interesting study, and to some extent it's a study that
Do you have
examines
Pokemon
who
like
we
this,
are.
like Anton
As
does?
the scientist in this paper
No?
mentioned, since we are made of
No.
cosmic dust, this literally allows us to see the true origin of everything in
That's
the
the
universe,
number.
including, of course, ourselves.
Like double
And by
views,
studying this
but
early
we don't
light,
have
we'll
that
be
number
able to understand
right now.
where everything in the universe came from and when it all began. For now, though, we just don't really have any telescopes capable of seeing this far back in time. We'll hopefully be able to do this in the next decade or so, but not yet. Anyway, on that note, check out the study and all of the relevant
I
data
really
and
can't
links
go
in
back
the description
and
below.
tell your
Subscribe
daddy
if you
to.
still haven't, share this with someone who
All right,
loves
well,
space
anyway,
and sciences,
catch you on the
and
next
maybe
one.
come back tomorrow to learn something.